In this video, I'm going to talk about families of functions, specifically quadratic functions. For now, there are two important questions. First, how do changes to an equation affect the graph? And second, how can we use that information to help us graph quadratic equations? A quadratic equation means that the highest exponent applied to a variable in the equation is 2. So the simplest example is y equals x squared. And we can figure out what the graph of this equation looks like by making a table of values. So we'll start with x, and we can choose 2, 1, 0, -1, and -2 for our x values. And then our y values will be the squares of those x values. So from there, we can find 5 points. So we've got 2, 4, 1, 1, 0, 0, -1, 1, and -2, 4. So now we can go ahead and plot these points. And you'll notice that they don't make straight lines. They don't make a V shape. They make this rounded U shape. And that's the shape of a quadratic function, this parabola shape. So y equals x squared is called our parent function. It has this shape, and this is the basic foundational shape of all quadratic equations. We'll see some others later that'll be based on this but changed a little bit. So suppose we change the equation a little bit to be y equals x squared plus 2. If you remember how to graph absolute value functions, this might be familiar to you. So we can pick the same x values we did before and make a new table. This time each y value is going to increase by 2. So we've got these new points, 2, 6, 1, 3, 0, 2, -1, 3, and -2, 6. So if we plot these new points, you can see that compared with our parent function, y equals x squared, the new graph is shifted upwards. It's the same shape, it's the same size, everything about it has stayed the same except that its position has shifted up the y-axis 2 units. That's called vertical translation. It hasn't been stretched or anything like that, it's just been moved upwards. So when you see an equation in the form y equals x squared plus k, some number k, that number k tells you how much that parabola shape will move up or down the y-axis. So if k is positive, we'll slide the shape up, and if k is negative, we'll slide it down. Now suppose we again change the equation, but in a little bit of a different way. Before, we had x squared and then we added a number. But now we're going to have x minus 1, and that whole quantity will be squared. So we're changing the quantity that's getting squared. So we have this example, y equals the quantity x minus 1 squared. So in our table, we can keep the same x values that we had before. And then we'll go over and apply that to the column for the y values and find our new points. So you notice again the shape of our parabola hasn't changed. And here it hasn't moved up or down, but it's actually moved horizontally over to the right. So it looks like subtracting 1 inside this squared term shifted the graph over 1 unit to the right. So when you see an equation that looks like this, y equals the quantity x minus h squared plus k, k is still telling you how to slide the graph up and down the y-axis, but that number h is telling you how to move horizontally along the x-axis. And it's important to note here that because the formula says x minus h, that means that, for example, if we had x minus 2, we'd move 2 to the right, whereas if we had x plus 2, that would move us 2 units to the left. So it's kind of like the opposite of what you'd expect because there's a negative already in the formula. Another thing to emphasize here is that because h and k tell us about this vertical and horizontal translation, the point h, k will be the vertex of the parabola, the place where it bends, the top or the bottom, depending on which way it's facing. So now let's look at another different kind of change to the equation. So we've got y equals 2 times x squared. So now we're not adding or subtracting anything, we're multiplying by 2. So we'll keep our x values the same again, and then each y value will be multiplied by 2. It'll become 2 times as large. So we've got our new points, and you notice when you graph these new points, the vertex has not moved. It's still at 0, 0. But the other points, for example, the point that was at 1, 1, has gone up to 1, 2. So its y value is twice as big. The point that was at 2, 4 is now at 2, 8. So again, its y value has doubled because we multiplied x squared by 2. So the parent function here has been vertically stretched. That's the last piece of this equation. So we've got this form y equals a times the quantity x minus h squared plus k. So a tells us how much to stretch the graph vertically. If a is greater than 1, it'll be stretched. If a is less than 1, like a half or a third, then the graph will be compressed vertically. It'll be squished down. And if a is negative, the whole graph will flip upside down. So that parabola U shape will become an arch facing downwards. So now that we've seen how each component in the equation can affect the graph, we can put it all together into one equation, and from that equation we can graph the parabola. So we've got y equals a times the quantity x minus h squared plus k. So we're looking for those three pieces of information, a, h, and k, and that'll be all we need to know. So here I've got this example, y equals negative 1/2 x minus 4 quantity squared plus 2. So we'll start with that vertex, that point hk, in this case 4, 2. So that'll be the vertex of our graph, and we can graph that right now. And now a is negative 1/2. So that negative means that the graph will flip and go from a U shape to a downwards facing arch. And 1/2 means that it will get vertically compressed downwards. Each point will only go half as far from the vertex as it would on the parent function. So if you imagine that parent function that has those points 1, 1 and 2, 4, those are going to be squished to only half as high, and they'll be flipped and moved downwards. So we start at the vertex, and you can imagine the parent function going over 1 and down 1. This graph will only go over 1 and down 1/2 a unit. And that point that goes over 2 and down 4 will go over 2 and down only 2. And this graph is going to be symmetrical, like the others we've seen. It's going to be mirrored around this vertex. So every point that exists on one side will have a mirror image on the other side. And of course, it's not a harsh linear shape, it's a smooth curve. So now to wrap up, let's go back to those questions from the beginning of the video. First, how do changes to a quadratic equation affect the graph? Well, we've seen that a, h, and k all affect the graph. They can flip it upside down, stretch or shrink it, slide it left and right, and slide it up and down. And how can we use that information to graph quadratic equations? Well, you've seen that h and k tell us where the vertex is. The positivity or negativity of a tells us whether the graph will be flipped upside down or not, and a itself tells us how much to stretch or shrink the graph. And you notice that all these functions look similar. They're a family of functions. They all have the same basic shape, but they can vary depending on a, h, and k. That's it for today. I hope you enjoyed. I hope you learned something. Thanks for watching, and have a great day.